Good morning, everybody. Welcome to the first open training workshop from the PISTIS project. So I'm James Philpott, one of the partners in the PISTIS project. And today we're going to be looking at data spaces, how they can help with greater data sharing and the impact that this might have on your company and your business. So a quick word about the PISTIS project. Through this European consortium, of which I'm joined by two other members who I'll introduce in a moment, PISTIS is creating a data trading platform that allows you to buy and sell different data sets from different European providers, safe in the knowledge that the data you are buying is high quality, it is in compliance with European legislation, and it is also traded in a way that is private and secure. So to give a background of why you might want to increase your data sharing and ways in which you can do that through participating in data spaces, as I said, I'm here with a couple of colleagues from the project. So we have Francesco Marzolo from Politecnico di Milano, who will be looking at data maturing, so pathways to data spaces and success stories. And then Luigi Mosca from Imperial College London will be looking at some of the consequences of moving towards human and technology collaborations that take place in data spaces. Once these presentations are done, we'll have a quick open discussion, but a couple of housekeeping items to begin. We are recording the session, so if you do want to contribute through actual discussion, please bear that in mind, and also you're free to turn your camera on and off as you prefer with that. For questions, you can enter them in the chat. After each presentation, we'll have a moment for discussion. And then if you want to follow up, you can also raise your hand and we can unmute you and then you can discuss with the presenters. And Luigi will be using Menti, so just to flag that to you, you can access either through the QR code that he'll be sharing, or we'll be sharing a URL in the chat so you can access it that way as well. But with that said, I think we'll get started. So Francesco, I'll pass over to you for the discussion on data maturing and pathways to data spaces.
Thank you, James. Good morning, everybody. So my presentation will be about data maturity, pathways to data spaces, and success stories. Let's begin by saying that according to a study by the European Union, 80% of industrial data is never used. For this reason, in April 2022, the European Parliament adopted the Data Governance Act, aimed at boosting data sharing in the EU, so that companies and startups could have access to more data that they can use to develop new products and services and potentially to exploit the potential of artificial intelligence. The Data Governance Act aims to create trust in data sharing, making it safer and easier, as well as ensuring it is in line with data protection legislation. This will be achieved through a range of tools, from technical solutions such as anonymization and data pooling, to legally binding agreements by their users. Building on the Data Governance Act, in November 2023, the European Parliament approved the Data Act, which made it easier for businesses to access large amounts of high-quality industrial data, especially coming from the Internet of Things. The Data Act removes issues standing in the way of reusing industrial data, making them more accessible and usable. Its primary objectives include facilitating data sharing, ensuring data sovereignty, promoting innovation and competition, and enhancing data availability and interoperability. For companies and consumers generating data, it clarifies who can use such data and under which conditions. In the vision set out by the European Strategy for Data, the creation of EU-wide common interoperable data spaces in strategic sectors aim at overcoming legal and technical barriers to data sharing by combining the necessary tools and infrastructures and addresses issues of trust by way of common rules. A data space may be defined as a distributed system with a governance framework that enables secure and trustworthy data sharing and exchange between participants. supporting trust and data sovereignty, and based on commonly agreed principles. A data space is implemented by one or more infrastructures and enable one or more use cases. Some principles for data spaces can be derived, such as decentralized infrastructure, decoupling of data producers and data consumers, safeguard of the data sovereignty of the data owner, defining and enforcing agreements on the use of data, including monetization, common ethical values like data ownership or privacy protection, level playing field for data sharing and exchange, data spaces structures able to support specific policies and regulations. Data spaces can be seen as a strong and collaborative alternative to platforms, or better, multi-sided business models. A possible representation of a data space structures can be seen in these pictures, where we distinguish technical building blocks that enable the implementation of the technical architecture through the integration of the different systems and platforms used by the participants to the data space, and governance building blocks that contain business, operational, and organizational agreements between the data space participants. The technical building blocks must assure data interoperability for efficient data exchange among participants, data sovereignty and trust to guarantee that participants in the data space can trust each other and exercise sovereignty over the data they share based on user-controlled consent. Data value creation to generate value from sharing data and create data value chains. On the right, we can see the data space governance. A data space governance is needed to configure and coordinate the necessary actions by different organizations, meet its objectives, and go through its different life cycle stages. In the governance building blocks, there are business agreements that comprise service level agreements, data usage and access control policies, as well as accounting and pricing schemes. Operational agreements, regulating policies that need to be enforced during the data space operations, and organizational agreements with terms and conditions regarding governance bodies and procedures established for a data space. Some of the sectors in which the implementation of data spaces has the potential to create high economic impact are manufacturing, green, mobility, health, finance, energy, agriculture, public administrations. As of now, the highest share of data economy's value is generated in the finance sector. The second largest share is represented by the manufacturing industry. Data sharing in industry has the potential to power strong growth, help companies optimize existing processes and develop new products, strengthen supply chains, and create new businesses. Data spaces for manufacturing represent a specific evolution of the general concept of data spaces, adapted to the needs and peculiarities of the manufacturing sector, where manufacturers, suppliers, distributors, clients, service providers, and other stakeholders can share, integrate, and use data collaboratively and securely as a powerful alternative to non-interconnected ICT systems which communicate bilaterally. In the case of manufacturing value chains, data spaces can have important impacts, such as increasing operational efficiency, for example, in production optimization, in predictive maintenance, reduction of consumption and costs, flexibility and adaptability of products and processes, monitoring and management of the supply chain, new product development, transparency in commercial relationships, risks mitigation and resilience, regulatory compliance. Manufacturing data spaces also facilitate improved decision-making and innovation processes and facilitate the creation of new business models. Technologies like IoT, digital twins, AI, machine learning ensure the exploitation of secure and scalable data sharing. The creation of federated, decentralized, and collaborative data ecosystems for smart manufacturing among players in the same ecosystems is one of the challenges of the European manufacturing. Several important initiatives to create standardized collaboration environments across entire value chains are taking place, such as, for instance, the Catena X value proposition dedicated to the automotive sector. Catena X, that incorporates the Gaia X principles, offers a sovereign, multi-tier data exchange across the entire value chain, enabling its participants to collaborate compliantly with one shared global data space. Its main focus is on use cases and common goals. Every use case offers business value for adopters and solution providers. Individual adopters are supported to become part of a dedicated Catena X use case and create instant value by offering them a multi-vendor and interoperable solution portfolio along their company journey. However, applications and benefits of data spaces extend much beyond the automotive industry. Here, we would like to bring some brief examples of concrete applications and benefits of data spaces to manufacturing industries from different sectors. As a first example, we shall mention a battery production use case. 90% of the ingredients of a battery are recyclable, but only if you use the potential of digitalization, we can produce batteries more sustainably. Battery data can help identify how production affects the performance of battery components. The production of batteries has a significant impact on their operation, quality, maintenance, and lifetime. Battery data have many different data sources at each stage of the life cycle, offering opportunities for data-driven quality and performance management in battery production. The management of information to enable the conservation and recovery of battery value can take place through the introduction of a digital product passport, enabled by a data space. The concept of a digital product passport is being pursued as a means of managing and sharing the data across partners. The digital battery passport will enable traceability of battery materials and components and managing complex information flows throughout the battery life cycle. As a second use case, we shall mention the optimization of the maintenance of machinery enabled by data spaces participated by the machine manufacturer and its customers. In this use case, the manufacturing company was able to integrate its customers' data platforms into a data space, so enabling a better after-sales service based on predictive maintenance service to customers and optimizing its supply chain. The third use case is a smart predictive maintenance for laser cutting systems. In this case, the participation in data spaces supported AI capabilities that analyze processes to improve predictive maintenance, which resulted in the productivity benefits, reduction of the cost of maintenance interventions, reduced spare parts inventory, increased machine life, and reduced maintenance costs at customer sites. Finally, as a fourth example, we are bringing the case of the services on a milling machine. In this use case, a machine manufacturer takes part into a data space together with its suppliers, components manufacturers, and its customers and users. Each has a part at different levels and with different instances. The outcome is beneficial for all of them. A reduction of in-site service interventions to check machine conditions, a reduction of costs related to machine guarantees, stronger relationships with the end user, resulting in income increase on spare parts sales. The participation in data spaces allow manufacturing companies to abandon the logic of data silos and gradually evolve towards systems of data bridges, data interoperability, and data valorization. The adoption of data spaces can impact on different functions of the company with different types of business management systems. They can impact on design and engineering of products and processes, impacting with the product lifecycle management, or on operation planning and execution and monitoring, production, maintenance, quality control, supply chain, in interacting with MES, MOM, supply chain management, warehouse management system, quality control system, and product performance monitoring and maintenance, sales and after-sales management, customer relationship management. The achievement of better data integration and continuity aims at producing actionable business intelligence. Business intelligence plays a key role in decision-making. Companies engaged in data spaces may achieve cost saving from improved operational efficiency, lower energy consumption, less errors and misinterpretation of data, better market scouting, faster development lead time for new products, higher growth in turnover and sales. Let's speak a little bit about trends. Within the large volume of activities around data spaces, I would like to mention the main technical and practical trends that you may meet if you decide to deepen the subject. Main trends are sector-specific, focusing on sector-specific ecosystem, integration of AI, blockchain, and IoT, decentralized models, edge computing, distributed ledgers, enhanced data sovereignty tools, inclusion of SMEs. We should also mention some major challenges. From a company perspective, challenges that could prevent SMEs from participating into data spaces could be lack of standardization, data sovereignty concerns, high investment, scalability, governance and trust, regulatory complexity. And from a general systemic perspective, major challenges could be estimating costs and benefits, balancing transparency and protection of sensitive information, authenticity and verification of data infrastructure, and the risk of creating additional superstructures of little use, if not hindrance to business companies. Overcoming these challenges will require global collaboration and consensus on issues such as data needs for circularity, data governance and verifiability, unification and standardization to create acceptance and garner participation. Data spaces are not simply technological innovations, but possible pillars of systemic change. Through the secure and transparent sharing of data, these tools offer new opportunities to optimize the use of resources, reduce waste, and promote more responsible production models. With continuing investment, collaboration, and regulatory alignment, data spaces will drive innovation, competitiveness, and sustainability. As already said, the participation in data spaces allows manufacturing companies to abandon the logic of data silos and gradually evolve toward systems of data bridges, data interoperability, and eventually data valorization by integrating them into companies' own business management systems. This integration is not immediate, but must be the result of an analysis that helps SMEs identify their own path of transformation based on their strategic needs and tactical capabilities. To this end, the Engineering University Politecnico di Milano in Italy has developed a model for assessing the digital and data maturity in SMEs, which allows transformation paths to be identified and suggested. This model is called the 6P, Data and AI-Driven Digital Transformation Model, and it supports manufacturing enterprises to assess their maturity in digitization and data use, and to track a data transformation roadmap. The approach is tactical, meaning that the company already has in mind its gap, but needs an effective set of actions to fill them. In case of a project, the roadmap is implicitly defined by the project, but the 6P is required to measure its impact. The 6P, Data AI-Driven Digital Transformation Model, takes its name after being built on 6 pillars that you can see in this slide. A basic assumption is that in order to succeed in a digital transformation process, it is important to boost not only the technical dimensions, but also the so-called social business dimension in a company. The 6 pillars, from which the name 6P, are product, process, and platform, clustered as technical pillars, people, partnership, and performance, the 3 social business pillars. Then each of these pillars contains 6 questions, that is 6 fields of analysis, and each question has 5 possible answers, corresponding to 5 sequential levels of development from the least to the most advanced one. Let's have a look to the 6 pillars. The first one is the product, that has the objective of evaluating to which extent the manufacturing SME is digitally mature in terms of product or product service system that it offers to the market. As mentioned, we have the 6 fields of analysis that are related to sensors and actuators, provided that the product allows the embedding of digital technologies, communication and connectivity, to measure how the product is able to communicate with external devices, storage and exchange of information, if the product is able to store and exchange data and to what extent, monitoring, to assess if the product is able to self-monitor its status, IT service related to the product, and business model enabled by the product. For each of these 6 questions, there are 5 standardized answers with increasing level of maturity. From 1 initial, for instance, the product has no sensor or no communication interfaces, to 5 exploited, the product can sense the environment and react autonomously. And the intermediate levels are 2 managed, 3 defined, and 4 integrated. The same pattern applies to the other pillars. The process pillar refers to the industrial manufacturing processes and refers to the transition towards automated, smart, and connected processes. It contains the dimension of design and engineering, production, quality, maintenance, logistics, and supply chain. Then we have the platform, referring to vertical and horizontal integration in the company. In this section, we talk about CPS and embedded system, industrial IoT, industrial internet, industrial analytics, vertical and horizontal interoperability of data and events, where by vertical we mean at company's level, and by horizontal we mean along the value chain. These 3 pillars that we have seen so far, product, process, and platform, are referred to as the technical pillars. Let's pass now to the social business pillars. The most prominent of these pillars is definitely people. A digital transformation process cannot ignore the involvement of staff. Actually, staff with their expertise are the real drivers of digital transformation. When operating a digital transformation process, staff skills, training, and involvement are the real heart of the change. For this reason, the 6P dedicates 10 questions instead of 6 to the people section. And in this section, we cross smart features with different types of professions in the company. The smart features are Industry 4.0 strategy, smart operations, smart supply chain, smart product service engineering, Industry 4.0 infrastructures, IT/OT integration, and big data. And these features are matched with different types of staff, managers and C-levels, professionals and engineers, operators and technicians. The last 2 pillars refer to the partnership, through which the organization identifies the partners needed for its digitization, such as Digital Innovation Hub, universities, IT providers, so on, and performances, suggesting possible KPIs to measure the transition. KPIs are not only operational and economic, as you can see here, but also refer to the ability of the company to measure its performances over other aspects, such as environmental, social, product service lifecycle, and supply chain. Finally, after that all the previous steps have been performed, radar charts will be released as outputs, 1 radar chart for each pillar. The radar chart allows to visually compare the current and the expected level. The blue line, that you can see here, corresponds to the maturity level before starting the journey, and the orange line, the level expected to achieve, or actually achieved if the transformation has been completed. And the pathway, the digital transformation pathway, is intended as the movement across the different levels of maturity, like in this case, where we can see an example of progress from data collection to bidirectional data flow. The same answers can be used to determine the level of maturity phased to the usage of data. In this example, we have the standardized answer to the question supply chain management, classified according to the table seen before, from no data control to data silos to data bridges and to data interoperability. Okay, my last slide is about a possible question that you may have, because data spaces can be an important opportunity to optimize the use of resources, reduce waste, and promote more responsible production models through the secure and transparent sharing of data, but we are still talking about complex ecosystems. SMEs interested in finding out more can contact these associations that you can see here, which promote the use of data spaces and help SMEs find their way by providing practical information. And they are the Big Data Value Association, Gaia-X, International Data Spaces Association, Digital Factory Alliance, Data Space Support Center, Catena-X, and Fireware Foundation. And probably there are more than this. That will be all from my side. Thank you very much for your attention.
Thank you very much,
Thank you,
Francesco. I don't see any questions in the chat, but if anyone wants to raise their hand, there we go. I was just going to ask quickly, if a company wants to use this 6P transformation model, how would they go about it? Do they need to contact you at Polimi, or they can find it on your website?
Yes, they should contact us. Then we should have some exchange of information to understand what is their purpose actually, and to have an understanding of their project, of their use case, because that will be the most effective way to apply the 6P without, but then just compiling it online without any other reference. So
Okay.
they can contact us, of course. They should
All
contact.
right, thanks. Yeah, and your email's there, and we'll send around the slides afterwards as well so people can have a look.
Yes, please. James.
Vasilis, I think if I allow you, you should now be able to unmute yourself, Vasilis, I think. It's in the bottom left-hand corner of the bar.
Yes, now I can see the option. Thank you. Can you hear me?
Yeah. Yeah, all good.
Thank you for this presentation. I was wondering, what is the role of data annotation in data spaces? Because I work in a not-for-profit organization in Greece called Science for You, and we have a project in which we have trained people with disabilities to annotate data so they can help build more inclusive AI models. And I was wondering, because this is a very, it was awarded, the project from UNESCO recently, but we are trying to help companies and the researchers build more inclusive AI models through data annotation. So what is the role of data annotation in data spaces?
Look, as far as I am concerned, I would more than enter into the technical details, because I'm more on the business side of the issue. I would recommend to address some of the institutions that I was mentioning earlier, such as the Digital Innovation Hub or technical providers, because they have a wide view over the world of application of data spaces, other different use cases. So maybe this is a special application, that one that you are mentioning. Maybe they can bring their experience into this. Actually, I have not that direct experience on data annotation in this application case. So I would please refer you to the entities that I have mentioned earlier.
Okay, thank you.
Okay, thank you, Vasilis. Thank you, Francesco. I don't see any more questions. So Luigi, we can pass the floor to you.
Thank you, James. Let me share my screen. I hope you can see my screen now.
Yeah, we can see it.
Wonderful. Well, morning everybody, and thank you, James, and thank you, Francesco. It's very interesting presentation. I'm Luigi Mosca. I'm a research associate at the Imperial Business School in London, and together we are going to see a little bit more about business ecosystems. You know, Francesco was talking about also systemic change that actually really connects very well with what I'm going to talk about now. We will then look quickly at data ecosystem, also because here we are representing PISTIS as well, and how network effects are created. And I will end this presentation talking a little bit about the human AI collaboration with the focus on decision-making structures. As James mentioned before, I will have some question for you. Very easy. We are going to use Mentimeter, some tools. There will be a QR code that you can scan with your phone, laptop, or tablet, or directly going to menti.com and insert the code. That will be a different code per each question, per each slide. But when we get there, you will see it's super easy. So what is a business ecosystem, right? So this terminology, this term is inspired by biological ecosystem, And the business ecosystem in general, they are defined as interconnected set of services in a single integrated experience. The interconnection here, it's very, very important because it allows us to talk about networks. So interconnected number of agents or units. This is very important here. When we talk about business ecosystems, we also talk sometimes about platforms. And a recent article by Jacobidis and other colleagues were trying to explain the difference. So when we talk about the business ecosystem and platform, why they are different. Usually, an ecosystem helps solve coordination failure amongst the partners within the same network. Platform, instead, they help solve matching failures, right? So try to put together two or multi-site market. So different stakeholders, different partners, different organizations from outside a network. This leads us to what we would like to focus today, that is the data ecosystem, that is in general a platform that combines data from numerous providers, so several providers, and builds value through the use of processed data. Hence, as we mentioned before, this is helpful for two main reasons. First of all, it's helped to build economies of scale by attracting participants through lower barriers to entry, and also helps to create a collaboration network. So when we talk about the data ecosystem, we rely on a platform that is enabling lower barriers to entry for other participants and also to enhance the collaboration. There are some elements of the data ecosystem. I go through this quite quickly without focusing on the technical issues. But important is this is also connected to what Francesco was saying before. The first thing of the data ecosystem is sensing, the first element, which refers to the process of identifying data sources for your project. And Francesco started this presentation exactly with this provocation about that 80% of the data are not used, right? So if 80% of the data are not used, it means that this first element of the data ecosystem is very, very important. The first thing is to identify the data sources for your project, your collaboration, your new product, and so on. Then data needs to be collected. This might be through manual automated processes. It depends on your organization. Then there needs to be transformed from raw data to something that is more usable, more useful for you. It needs to be analyzed. So there are different algorithms, ways, statistical methods, data visualization tools. Here, and later I will share the slides, you can also find some examples, some tools that you can play around and try to understand how to analyze your data. And of course, they need also to be stored, right? So they can be stored somewhere, might be cloud-based, on-site, or through some storage media, and then can be used and reused, or in some cases also can be sold, right? So data ecosystem, very, very important, and also key for SMEs, larger organization, and for collaboration. And these elements are really, really important when you consider to start to develop a new data ecosystem or to join a new ecosystem. Now I have a question for you, and it's exactly related. What do you think is the biggest consequences for SMEs joining this AI-driven data ecosystem? So we were talking about why these are important. If you are in SMEs, what's going to be the biggest consequences when you join this data-driven ecosystem? So to address this question, I can see already 4 people responded. To address this question, you can go on menti.com and use the code 57240379 or directly scan the QR code. The alternatives are access to a better insight and innovation, increase dependency on digital platform, new revenue opportunities, and I can see already here, greater regulatory governance complexity, or loss of control of proprietary data. These are, they are not only benefits. But apparently, here we have access to better insight and innovation, as well as greater regulatory governance complexity. I see these are, let's wait a few seconds just to see. Nice. $11. Okay, should we say we were winner? Definitely, I can see that. Oh, okay, not yet. We can see that for SMEs, definitely it's important to have access to better insight innovation. So there will be very nice consequences if you join an AI-driven data ecosystem, as well as new revenue opportunities from data. This is one of the most important things. This is also why PISTIS is focusing on this new platform for sharing data. All right, we will have other questions, and also, at the end of this presentation, happy to address some questions or to open up for a conversation, actually. Networks, that these are, quite, the network effects are quite important, and why, and how they are created. Of course, this is very basic. The simple agglomeration of user, okay, so many people together, or many organizations, actors, does not create network effects, okay? As some tools that enables the interaction that define them also is needed. Very simple. Network effect in the phone network cannot exist without the telephone itself. Super simple. Similar WhatsApp creates a space to receive a message, or X, former Twitter, creates a feed. These are tools, software product actually, that enable the network effect. So this software, this kind of product, this software product enabling network effects are also defined as data product, because they are based on data produced by or gathered from users. So they rely on the users, or they create. For example, in the case of WhatsApp, the messages that users create, right? Or the post of X, Facebook, Instagram, TikTok, or whatever. Or even the comments and rating that are created, that, users, buyers, they can post on Amazon.com. We have a network effect per se, even without any kind of transformation. So you have the feed, there is a comment, and so on. However, the technology can enrich this network effect, okay? You can image Instagram, so people by adding comments, adding likes, reposting. So this software product that can actually enact and enable the network effect. However, here we are talking about AI, and this can be really, really interesting in this case. And happy to talk a little bit more about this, because actually through the use of the AI, you can enhance the algorithms, and then you can also increase this network effect within your own platform. And, there were also the example I just made. You use AI, you use the human effect. At the end, the multiplier of your network can be enhanced and improved even further if these two things are combined. Both the AI intervention, if you like, the AI use, and the human use. So it's very important, or at least this is what already is happening and will happen more in the future. That is basically the AI use, any kind of technology, and the human use, they collaborate together in order to enhance the network effect. And this will then lead to the idea why we need this human AI collaboration. It's underlying this idea of how we can enhance and improve our networks. And then I have another question for you. There will be, how comfortable will be your organization be relying on AI to support important business decisions? Because, as I said before, the most important thing when we talk about human AI collaboration, at least the most important thing that we are going to talk about today, it's really the decision-making process. In this case, we have the code is 57240379, or feel free to scan the QR code here. The question will be from 1 to 5. So very quickly, you can address this question. What do you think? So before we start talking about decision-making processes, are you going to feel comfortable to use AI to support important business decisions? And important, I mean key for your business goal. There is this moderately comfortable, always in the middle, that gets the majority of the votes. But I also see some people actually going very comfortable. So it means there is a willingness to actually use AI for the business, for important business decisions. But apparently the moderately comfortable is still the dominant answer, and understand that because I guess the reason behind this answer is because we don't know yet how AI thinks and what kind of decision will be made, and most importantly, if these are core for our business, who's going to be responsible for that? And we are going to touch a little bit about this in a sec. So thank you for this. We will have other two questions at the end of the presentation. Human AI collaboration. We saw it's important for the network effect. It's important for business decision and for decision-making processes. Let's see now how we can structure these decision processes within our organization. So first of all, AI, it's a bit different from the other kind of technology revolution that we had so far, right? Because AI refers to machine agents that perform cognitive functions that we associate with human minds, right? So as perceiving, reasoning, learning, interacting with the environment, problem solving, decision making, in some cases also about the creativity process. In the past, we had other kind of different kind of revolution, if you like, because for example, we had steam power, the electricity. These were technology that were enabling human to overcome the physical limitation. Here, for the first time, let's say it's so evident now that AI allows human to perceive and process information in a totally different way, most likely even in a superhuman level, if you like. Probably something that I forgot to say, as you can see, I have the references in the bottom right of my slides. And if you have access, or if you want to read, if you don't have access, if you want to read more, just contact me. I'm happy to share these references so you can find them online. And at the end of the presentation, I also have a link to my ResearchGate profile where you can download some of my work on this stuff. Well, studies have found that AI can improve efficiency, profitability, enabling humans to focus on more value-adding and rewarding tasks. We know that, right? That will be good. We use AI so that we can focus on the most important thing, and AI can solve basic problems. Okay, this is something that we have found so far. The most important thing is how we're going to use for organizational decision making. And the next few slides, I'm going to talk about this and the different structures. What I mean by organization decision making is the designing where, when, how to make integrated decision involving group of individuals, people. There's be a cornerstone concerning the business management. So involving the group of people together with AI. So when we are going to do this, there are different alternatives. Are we going to use AI at the beginning of the decision-making process, at the end, together, in parallel? How we are going to use AI? Let's see the different processes. There's something that it's important here to highlight, that when we talk about organizations, in particular, I'm a researcher in focusing a lot on the business model, organizational levels, but there are even different professions that AI is helping people, actors, to take decisions. medicine, in psychology counseling, human resource management, in banking, in transportation, in public administration. So definitely the use of AI to take decisions or to enable humans to take better decisions, it's something that probably it's so disruptive and is probably related to all the kind of industries. So it's a really big team right now, and I think it's pointless to say it's everywhere. There are also some issues that we need to consider when you use AI. This is, reflecting your previous moderated kind of confidence in using AI to take decisions. This because there are hidden biases and challenges. We don't know the transparency of decision-making process using AI. The accountability is going to pay for the wrong decisions, and so on and so forth. So how are we going to do? What are the cases? So there are 3 decision-making structures that have been identified, or at least potentially, then there are other ways. We are going quickly to see these 3 ways and when they are used and why they are helpful. One is the full human to AI delegation. We delegate AI everything. Hybrid, for example, some decision are taken at the start of the decision-making process from the AI, or the other way around, we use AI to make the final decision, or basically totally aggregate, so together in parallel. Full human to AI delegation, we have AI-based algorithm make decision without human interventions. Seems kind of futuristic, it's already there, out there, it's already used. The problem is, one disadvantage, human decision maker, however, still retain responsibility for the decision. So how we deal with that? This is an open question. So what are some cases here that we can have? Full delegation includes, for example, traffic planning, real-time product recommendation system, dynamic pricing, imaging one or airlines, hotels, online fraud detection, and your recommendation of the product through Amazon or streaming video when you use YouTube or Netflix. These are all decisions that are already now full delegated to AI systems. Then we have this kind of hybrid structures that is interesting because it actually can enable to use it to benefit the advantages of to have both human and AI capabilities, but also all the disadvantages and the weaknesses. Let's see. The first scenario is AI-based decision-making is applied to the initial set of alternatives. Okay, so it means that AI functions, AI tools, they are used as a filter that reject redundant or inappropriate alternatives or set of ideas that then the humans are not even going to consider. Right? This is, for example, when expert advice and offer recommendation a set of alternative to a decision maker with authority of final decision, and allowing the decision maker to exercise discretion with respect to whether or not use an expert advice. So AI will take the first initial set of decision, and then an expert, a human, will actually take the final decision. This might be, for example, use application crowdsourcing. Many ideas, thousands of ideas that are bring to within any companies or during an R&D project or whatever, and then AI can select the one that are not helpful, and then soon after, when you have it in smaller pool, let's say, then the humans, the expert in the sector can actually take the final decision. Healthcare monitoring, hiring, very common example, where how many times we heard that now AI algorithms are screening CVs and so on and so forth. This is the typical case. So AI is screening your CV, and then if you pass the AI test, then there will be someone from the other side, a human being, that is actually going to look at a smaller pool of CVs and actually conduct interviews. Then we have when human decision, they make first the decision and then they will use AI. This is when basically the human are high confidence that they can narrow down a small set of preferred alternatives, and then the AI can choose the best one, or at least the one that might be the best in the long term. And to give you some example here, we have also in healthcare, the structure fund application in AI-based monitoring of bodily functions, heart rate, temperature, blood pressures. This might there are some of the cases because deep learning models process anonymized electronic health. They take some decision and then so the human will take first some decision and then the AI will analyze what's going on and probably can take a final decision. In this structure, there are some pros and cons, as I said before. When we have, for example, in hiring, human decision maker may focus on more difficult to define factors, such social fit, and then leave it to the algorithm. So what I mean here is there is not always the best way to delegate, and even these hybrid structures might be even better to think about the strengths of the humans and the AI. So when actually we can make the difference, at the start of the process or at the end. So this hybrid approach seems to be quite interesting, seems quite strong, but it needs to be designed very well at the beginning of the process. And I have a question for you here, because now that we see that there are different pros and cons, different structures, different way, what are the barriers for your organization to actually participate in the data ecosystem? And then we will see also to have some, I think still we have 5-6 minutes, some conversation about decision-making process. So please use menti.com. The code is 379 or scan the QR code. Here you have some options, but as I said, in the last 5 minutes, we can also look at the options, because here probably the barriers that will be identified are related to data governance and legal concerns, lack of technical infrastructure, unclear business value, and I think also Francesco mentioned some of these ideas earlier, lack of trust between organizations. This is probably, I can already see it here, a limited internal data skills. But apparently data governance and legal concern at the moment is the main concern. There's still 4 or 5 people ready to answer. Probably they're still thinking about. But I can say that, yeah, I mean, thanks for, addressing this point. It's definitely a good point. Data governance and legal concern are the main issues here. It's quite evident. And then clear business value. I think this is something that I'm working in particular with the PISTIS project, is also try to understand how we can create business value and how we can create value and capture this value by using this kind of platform to enabling data sharing. So it's something that we are working on. So, but I can see it's the second main concern. Last question for you. How does your organization currently use data in collaboration with other organizations? If so, the code is 57240379. And the option are we actively share and exchange data with partners. Occasionally, we must keep our data internally. Oh, we don't share at all. Interesting. We actually share and exchange data with partners. At the moment, it's 0%. Amazing. And not surprising, you share data occasionally for specific project. It seems to be the majority here in this case, the 50% of the respondent, 53. But it seems quite. I think this is really the case across different industries. Well, I want to leave. So I was rushing a little bit in the final part because I want to leave some time, at least a couple of minutes for questions. So thank you for this. As I said, here, if you want the articles I mentioned, contact me. This is my email address. You can find some of the work. You can download some of the work for free, of course, through my ResearchGate. This is the QR code to my LinkedIn profile. Happy to stay in touch. Thank you so much. And James.
Thank you very much, Luigi. I actually wanted to say that second to last poll is very useful for us because now we know what to do our next training workshops on. So PISTIS can organize one on data governance and legal concerns, and then one on determining business value of data. So that's very helpful for us. Just check with the floor. I don't see any comments or questions in the chat, but in case anyone has anything, feel free to raise your hand. And
there is a comment, you don't know how AI thinks because we don't know how the human thinks. Well, it's a kind of provocation, but that's true. But, at least what I can say, it's the way how we have run things so far, right? So now, and it's on our judgment, suddenly giving important decisions to a machine that you don't even know how to take this decision, what kind of data is analyzed, is always kind of risky. And yeah, according to polls that we just had, it seems that is still the case.
All right. Before we finish, I just want to share one final slide. So if you want to know any more about PISTIS, or if you want to learn about the data trading platform itself, there is an upcoming Living Lab. So that's on the 26th of March. This is focused on the aviation sector very specifically. There will be a couple more Living Labs in the future that are a bit more domain agnostic. So if you're interested in learning how the platform works and potentially using it to trade data, I would encourage you to check out those links. Here on screen, you can see our massively online, I remember what the other O stands for, our MOOC. So this is found on YouTube. Here we have a range of different topics around data trading, around the data economy, that the PISTIS partners have produced. So this is a really good resource if you're interested in beginning or following your own data trading journey as a company. And finally, at the bottom, we have the PISTIS website as well. So you can use these links to learn more about the platform. And Luigi, really interesting presentations, and I hope everyone in the audience to see you again at the next workshop.
Thank you to you,
so
James.
much.
Organizing.
Thank you.
All right. Bye-bye.
Bye-bye.